mentioned your interest in joining the Marines or the military. I don't know if you ever heard of MREs. Have you? No? Okay. So when you're out in the field, this would be your food supply. So this right here is your main course, which is penny with vegetable sausage crumbles. Delicious. So now, where does chemistry fall into this? Well, I want to show you this cool thing. So when you're on the field, you actually have this heater, and you get to heat up your food. So we're actually going to do that right now. So here you go. Here's your heater, and then make sure, so you put it in there. Yeah, just slide it in. Try and get it, behind the heater. Okay. Yeah, just try and, so you kind of want the heater, we'll just slide it out. There we go. Alright, so now we're gonna just down. There you go. And then you're gonna take the water and you're gonna fill it in between the lines. Don't fill it over. I'll hold it while you pour. And then just stop me. Keep going. Yeah, it's good. Okay, so it's been a few minutes. Why don't you take the bag out and feel it for me? It shouldn't be too hot. Okay.
Oh yeah, that's very warm.
Right? Okay. So this is actually how you heat up your food, and then I guess after a few more minutes or so, you could take it out and you'd actually eat it. So I have a question. What type of reaction do you think that is?
I believe it's an exothermic reaction.
Okay, and why do you think that?
Because I remember, like, if it, like, releases heat, that means it's exothermic, and if you touch this, it's very warm. And
it's hot, right?
Yeah,
so that's how you know that it's releasing the heat. So this, right, so this is chemistry in the military. So one of the neat ways that you can actually incorporate chemistry. Okay, so now we're going to do a small, easy reaction, and what's cool about this is we're going to perform 2 endothermic and exothermic reactions. You're going to be able to actually collect the data wirelessly in real time using this wireless probe temperature thermometer. That's what I meant to say, my bad. So this is a wireless thermometer, and it's connected to this app where it's going to collect the temperature change in real time. Okay? So we have the instructions for the lab right up here. So you're going to add 1/3 cup of water into this cup first. Yeah, that's perfect actually. It's up to the line. Okay, then the next thing is to add the dry yeast, which was already measured out for you.
Alright.
Cool. Okay, now hydrogen peroxide. So measure this, you're going to pour 1/3 cup. So you can just pour it here if you want to hold it, and then that way we don't make a mess or anything. And you pour that into there, and you're going to want to stick the probe in and just stir it. There you go. And then we're going to collect the data, and we can actually see the change. Okay, so see how it's really. Alright, now you can kind of see, look how the temperature's starting to go upward, and it's pretty cool reactions.
Yeah, it's bubbling up.
Yeah. It's kind of like similar like the reaction we did prior, except instead of the temperature going up, it was going down. Okay, so now that we've completed both reactions, I want you to answer these 3 questions on the lab that we did. So you can refer back to the data here that we have on the app to help support you.
Alright, so the first question, which reaction was endothermic and why? The reaction with the lemonade mix and the citric acid was endothermic because like on the graph the temperature decreased.
Right, yeah, which you can see right here, the temperature is decreasing. So with the citric acid, which was in the lemonade mix, it was an endothermic reaction. Perfect.
Which reaction was exothermic and why? The reaction with the H2O2 and the yeast was exothermic because the temperature increased instead of decreased.
Right, yeah, so in the second reaction that we did, we actually saw the temperature increasing, as you can see on this graph. So therefore, it was an exothermic reaction. Good job. And then the last one, let's see, explain why the data on the graphs are or are not in a straight line. So why do you think?
Well, not on a straight line because depending, like if it increase or decrease, the line's not going to be straight, and it just depends on what reaction they are.
Right, good job.
So-
Yeah, so in endo and exothermic reactions, there's some sort of temperature change.
Mhm.
So if it was a straight line, then that means
Nothing happens.
there's no reaction, there's no decrease or increase in temperature. All right, I think we're good.